Hello, everyone, and thank you for joining us today. For those who don't know me, my name is Jill Gallegos, and I am a microbiologist and technical sales rep with Gusmer, who covers Texas. Um, Gusmer manufactures and distributes many products used in the winemaking industry here in North America. And one of our partners, Christian Hansen, who makes yeast and bacteria. David Spector, my associate, is here with me today to present. David started out his winemaking career after joining a winemaking club in his hometown of Philadelphia. He knew his passion would become a lifelong quest. After pursuing his undergraduate degree in economics from Penn State, he completed a handful of vintages around the world and then earned a master's degree in enology from Cornell. Working in a variety of functions from winemaking, quality, Lean Six Sigma, and sales for very large winery groups such as Gallo, Constellation, and Vintage Wine Estates, David has acquired a number of entertaining stories about the wine industry that he may or may not share with you. Currently, David works for Christian Hansen and travels the world to assist winemakers and brewers with fermentation expertise. When not traveling, he can be found working from home or at his favorite coffee shop in Venice Beach, California, where he lives with his wife and cat. So let's welcome David Spector.
All right. Thank you for that wonderful introduction, Jill. I really appreciate it. Yes, I am in Venice Beach. I know people think palm trees and beaches, but I'm wearing a jacket. It's pretty cold. It's 65 degrees here, so I like to be warm. I like to begin with a story. You know, humans have been making wine for thousands of years. And I'd like to take you back in time and tell you a miraculous tale about winemaking. No, not that story about Jesus turning water into wine. The story that I'm going to tell is not found in any book. No, we're going back to the 1980s, which is in fact a very recent phenomenon when you think of the vast timeline of our winemaking history. In the 1980s, Christian Hansen, the leader then and now in bacteria fermentation, formed a wine team. That's because Christian Hansen recently converted the dairy industry from using starter cultures to freeze-dried direct inoculation cultures for cheese making. And in this new wine team that they hired, they had found a dynamic duo. First, there was Klaus Prahl. He was gregarious. He was a lover of French wines. Who isn't? He spoke 6 different languages and played multiple musical instruments. And then there was Jan Clare Nielsen, introverted, methodical, and bespectacled, who was a brilliant researcher who collected hundreds of bacteria samples from wineries and universities around the world. If you're interested, you can certainly go to the research articles in the 90s and you'll find many papers on malolactic fermentation from these 2 gentlemen. But 20 years before this dynamic duo was hired by Christian Hansen, a researcher named Ellen Garvey published a paper which spoke about a new species, Leuconostac enos, which we now call Oenococcus oeni or Oenococcus oeni. With my Philadelphia accent, I prefer Oenococcus oeni, so that's what I'm going to use. But if you want to say Oenococcus oeni, go right ahead. So in this paper, which I can send to you after this presentation, you can see that researchers such as Dr. Kunke at Davis and Pinot at Bordeaux had collections of Leuconostac enos in their collections. And as a former employee of Constellation Brands, which owns Robert Mondavi, I often heard rumors of Mr. Mondavi driving down from his winery in Napa down to Davis to pick up his slant of bacteria for malolactic fermentation. But everyone knew, especially the researchers at that time, that wine bacteria was different than those used in dairies. So producing bacteria, concentrating it, freeze drying it, and then having it convert malic to lactic in wine, after being directly inoculated, it wasn't possible. But our dynamic duo, Klaus and Jan Claire, they didn't believe that. They knew that it could be done, and that was their call to action. And so they set off every day in this laboratory in a far off corner of the building. These two mavericks smoking cigarettes and building a collection of strains that would go on to fill two dusty old freezers. And I often wonder if they knew that their work would have such a global impact, especially since they were just a stone's throw away from where Emil Christian Hansen isolated the first pure cell of yeast at the Carlsberg Brewery in Copenhagen about 100 years before. But after a few years of work, Klaus and Jan Claire successfully made a product that could withstand the freezing process, yet was robust enough to work in the harsh environment of wine after direct inoculation. And off Jan Claire and Klaus went to Bordeaux with their magic powder. And it was good timing because that year Bordeaux was experiencing cold and wet vintage. Malic was high and none of the wines were going through malolactic fermentation. We know that wineries can utilize the indigenous and native yeast and bacteria to perform primary and secondary fermentation, but there's risk. And so when Jan Claire and Klaus arrived in Bordeaux, they thought that they were going to get a hero's welcome. They thought folks would be cheering, they'd break out the palms, and that was not the case. While most of these wineries were having difficulties, they couldn't get their wines to go through malolactic fermentation, and that's especially concerning as they like to blend the wines before the winter. So they were looking at a very long winter where their wines were not going to be able to be blended. They were not going to be able to add SO2. They were not going to be able to chill their wines to protect it. And Klaus and Jan Claire went around and said, listen, we have this freeze-dry bacteria. We think that it's going to get your wines through malolactic fermentation. And the winemakers in Bordeaux, they went to the researchers at the university and asked, and the researchers said, no, there's no way that they can freeze dry Oenococcus oeni and have it ready for direct inoculation and put wines through malolactic fermentation. It must be something else. Jan Claire and Klaus were able to find one winery that would take a chance. And this was no ordinary winery. This was a first growth chateau with an American dialect. But this American princess who owned the winery wasn't just going to let our dynamic duo in the front door in the middle of the day. No, word travels too fast in Bordeaux. So she told them that they could inoculate her wines worth millions of dollars, but they had to come in the middle of the night. And so Jan Claire and Klaus, they snuck in under the cloud of midnight and they inoculated all the wines. And a few days later, they got the call. malolactic conversion had begun, and it was just a few weeks later when they confirmed that all of the wines at this particular chateau had gone through malolactic fermentation. Well, we said that word travels fast in Bordeaux, and all of the other winemakers who still had wines that were not going through malolactic fermentation were getting quite worried. And they said, look, it worked at this chateau. We want some of this magic powder that they have. And so they worked with the University of Bordeaux. They worked with Christian Hansen's Klaus and Jan Claire to distribute the bacteria so that all of the wines could go through malolactic fermentation. And they did. And it was only just a few short years before all winemakers around the world now had this tool in their arsenal. Freeze-dried direct inoculation, Oenococcus oeni, for malolactic fermentation. So you've been introduced to Christian Hansen through the tale that I just told, but I want you to know that we don't just take a reductionist approach to winemaking. We're not going to just focus on one element, but the fermentation process holistically. That's why we offer pre-alcoholic fermentation products, primary fermentation products, and a whole range of Oenococcus oeni for malolactic fermentation. This is a simplified image of the traditional sequential fermentation process. Obviously, there are other actors in play, such as Acetobacter or Brett, but I think this visual does a good job showing the rise and fall of different microbial populations. And we're going to touch on the topic of different inoculation timing, co-inoculation versus sequential inoculation, a little bit later in this presentation. So each strain of bacteria is different, and the selection of your Oenococcus oeni strain can have a major impact on your malolactic fermentation. So you want to look at the alcohol tolerance, the pH viability, the SO2 tolerance, because they vary by strain. And if you remember one thing from this presentation, I think this is it, that each strain of Oenococcus oeni is different. Let's use a different species, for example, to drive this point home. Let's take Homo sapiens. So I know most of you are in Texas, and I'm from Philadelphia. So I will use a Philadelphia example because I don't know who the quarterback is of the Cowboys. So Carson Wentz is the quarterback of the Philadelphia Eagles, and Carson and I are both part of the same species, Homo sapiens. And while I may be a little bit better looking than Carson, he can throw a football further than me. We're different. So same thing with Oenococcus oeni. Just because it's the same species doesn't mean that each strain is the same. We'll go through some of these strains in a little bit more detail, but just to give you an example, perhaps CH35, that's a strain that produces more diacetyl. So if you're looking to create a buttery Chardonnay, that might be the strain you look for. We also have an ethanol resistant strain, CH16. So that would be the strain if you are making high alcohol wines. In the next 3 slides, I would like to outline what we mean by MLF, how it takes place, and why conduct malolactic fermentation in a given wine. So what is MLF? Well, it's the enzymatic decarboxylation by specific lactic acid bacteria, predominantly Oenococcus oeni. Now, what does that mean from the wine's perspective? Well, one, it decreases the wine's acidity. as lactic acid is a weaker acid than malic. Two, you're going to have changes in the organoleptic profile of your wine. That might be from the production of diacetyl, acetic acid, or even the modification of esters. And finally, malolactic fermentation makes your wine more stable, as the bacteria will consume available nutrients and removes a fermentable substrate to mitigate against other spoilage organisms. A quick note on spontaneous malolactic fermentation. We all know that one could conduct MLF with indigenous bacteria from the grape or even winery equipment. And we know that Oenococcus oeni can survive in barrels. And some of the most famous wines and wineries in the world do that. But there are risks, and it's good if you know what those risks are. One is speed. Do you want to finish malolactic fermentation before winter so you can chill and SO2 your tanks and barrels? That was the concern that many of the winemakers in Bordeaux had back in the late 80s and early 90s. What about unwanted sensory compounds from other microbes such as acetic acid, ethyl acetate, bread off aromas? Do you want to take those risks, especially if you have vintage to vintage variation? And then finally, there is the production of biogenic amines. We test all of our bacteria for the production of biogenic amines, but if you are relying on indigenous bacteria, you could have some strains that produce biogenic amines. In a recent study conducted with many of our customers around the world, we found that a lot of the quality issues folks see could be solved by proper management of malolactic fermentation. According to this survey, things like high VA, bread off aromas, unclean, vegetal, these are all things that your malolactic fermentation, mastering that process, relying on different strains can help you mitigate. Now, to better control our fermentation, we need to know our main character, Oenococcus oeni. And yes, this creature has curly hair because its creator has curly hair. I thought that would help with consistency. But this is a simplified visual. And I don't mean to say that these four conditions, temperature, SO2, ethanol, pH, are the only conditions that matter. Wine is a very complex matrix, but we feel at Chr. Hansen and Guzmer that these are the most important. And so now we're going to take a quick look at nutritional considerations for malolactic fermentation, which Jill will lead this section.
So why do we need nutritional supplements for malolactic fermentation? There are a few reasons. The lack of nutrients can cause sluggish or even stall malolactic fermentations. Wine finished with alcoholic fermentation can often be deficient or void of nutrients. Certain Saccharomyces yeast strains take longer to lyse, trapping nutrients with their cells that malolactic bacteria might otherwise be able to use. Oenococcus oeni cannot store nor synthesize all essential amino acids. So when should you use the nutrients for your malolactic fermentation? Nutrients are recommended whenever you have challenging conditions like high alcohol, high SO2, very low pH, temperatures on the extreme ends of the fermentation range. Highly clarified wines can lack adequate nutrition for MLF. Certain varietals have historically been difficult to put through MLF, and your own experience is vital. You know your grapes and your grapes' conditions. Previous vintages can predict how the current one will behave. Some hybrid varieties can pose interesting stylistic issues with high malic acid content.
All right, thank you, Jill. So back to wine as a stressful environment. We've outlined a few of the conditions for your malolactic fermentation, the big four, as I call them, highlighting what is favorable and which are difficult. To some degree, you have more control over temperature and SO2 of your wine than you may of ethanol or pH. So those temperature and SO2 are definitely levers that you want to pull, because these conditions um, can have a synergistic effect. So if you have high SO2 with high ethanol and your temperature is too low, those can work against you. So be mindful of trying to get into the favorable conditions where you can. Now, I'm a big fan of transparency, so I'd like to share a bit on how we screen and produce our bacteria strains. It's not something that folks often talk about. We look for strains with unique and robust characteristics, and we have to get these strains from nature. Now, that can be through a variety of means, such as the grape, or from the wine, or even winery equipment. I'm going to take you through the production process. Many of you may have seen our Christian Hansen freeze-dried packs. So I want to take you to the beginning on how those are made, because when I was in university, I just thought that this was a tool that winemakers had since the beginning. But this is, a relatively new phenomenon, as we talked about in the story. So there are 6 production plants in the US and Europe. The closest production plant to you in Texas is our US production plant in Milwaukee. In today's world, I think it's very important to know your suppliers and what values your suppliers have. We're headquartered in Denmark and have been named one of the most sustainable companies in the world. The fermentation process is very much like a wine fermentation. I think if you came to one of our plants, you would feel quite at home with the fermentation tanks. The exception would be that we are prioritizing biomass over conversion to lactic acid. And we freeze the bacteria as our end product, and then we can further process it into a freeze-dried material, which gives the product a longer shelf life. Here's how we store it. We have very large freezers at Christian Hansen and Guzmer, and you get to wear clothes like this gentleman if you go into the freezers, because it's very, very cold. You can only stay in there for a bit. And then we are transporting these products cold for the frozen product, and we can ship the freeze-dried products at ambient temperature. And we work with Guzmer to get our bacteria, whether it's made in Europe or in Milwaukee, to customers that Guzmer has throughout North America. And then finally, use. All of our products are made to be directly inoculated into wine. There's no need to rehydrate, and all of our products are made with the recommended dose that when you put your bacteria into your wine, you know that malic to lactic conversion is going to occur right away. Let's chat a little bit about what makes the Venaflora range special. We know that there are one or two other companies out there that make bacteria for malolactic fermentation. One of the things that is special is that all of our products are ready to be directly inoculated. And we also test every one of our batches for their ability to convert malic to lactic quickly. We call that test the MAC test, MACC. Other quality measures, which we take to the next level since we are part of the dairy industry as well, and their needs for sterility and avoidance of yeast are even higher than what we see in the wine industry. So we share all the different contaminants that we test for, making sure that there's no yeast or acetobacter in your product, but you're getting is pure Oenococcus oeni. And finally, we share the importance and ensure that each of our products contains the magic number. And so what is the magic number? It's something that we at Christian Hansen and Guzmer talk a lot about with the industry. The magic number is 1,000,000 cells per milliliter. And we believe that that is the number of cells needed to start malolactic fermentation. And you should know that not all products on the market will deliver 1,000,000 cells per milliliter. And that's very, very important to know because Oenococcus oeni grows so slowly, where Saccharomyces cerevisiae can double in a matter of hours. Oenococcus oeni can take days to double. So if you are looking to conduct a malolactic fermentation quickly, you need to have the proper amount of cells or your conversion will not begin. And that's why it takes so long to complete malolactic fermentation if you're using other products or if you're cross-seeding or you go spontaneous, relying on indigenous bacteria. This is a little example of the time difference between direct inoculation, cross-seeded, or some people call a mother tank, and spontaneous. You can see that with direct inoculation, this is an Australian Cabernet. They completed malolactic fermentation in less than 20 days, where you can be months with spontaneous. Sometimes winemakers will need to wait until spring for malolactic fermentation to complete if they're going spontaneous. So I'd like to talk a little bit about co-inoculation. I will give a bit of a disclaimer. With co-inoculation, you really need to understand the chemistry of the wine and know if is it right for you? Is it right for your winery? Is it right for your particular type of wine? You know, there are a lot of benefits that one can get from co-inoculation. You can save time, you can save cost, you can enhance fruitiness. And I'm really seeing, especially in the last 5 years, a lot of wineries really take a good look at co-inoculation and obtain the benefits. For a long time, co-inoculation wasn't that popular. The inoculation of Oenococcus oeni into must and juice along with yeast was proposed originally because it was felt that nutrient availability would be enhanced, and the absence of ethanol early on in the process would allow Oenococcus oeni to better acclimate to the environment conditions and grow more vigorously, really allowing you to get that malolactic fermentation done quicker. a lot of the research that I've read has found that the presence of rapidly growing yeast was antagonistic toward bacterial development. And the point at which bacteria transitions from a lag phase to a logarithmic growth phase is coincident with the onset of yeast death. And I believe that's the result of yeast autolysis returning those essential nutrients to the system. And so that's why it's very important to understand, your wine. Do you want to conduct an early co-inoculation? We consider that about 24 hours after yeast inoculation, or do you want to go with a late co-inoculation? We consider that occurring in the last third of primary. I know in Texas, there are a lot of red wines that have high pHs. And usually we suggest going for co-inoculation only if you have a pH lower than 3.5, 3.4. And the reason for that is because that Oenococcus oeni is going to prefer malic acid and converting that to lactic acid. Once you get above 3.5, it may go for sugars, and you are creating the conditions that are also favorable for other types of bacteria that may produce some compounds that you don't want in your wine. And so, here is what depopulation peaks look like with co-inoculation versus sequential inoculation. There's another category that we call reverse inoculation. That's when you are inoculating with bacteria before yeast. Some winemakers around the world will employ this type of process, but they actually use a different type of bacteria called Lactobacillus plantarum, which is not available for use in the United States, but I think it's good to know that it is possible, in some wines that you may import from France or Italy may take this approach. And here are just some guidelines on co-inoculation, if you should use it, if you should go early co-inoculation or late co-inoculation. And just a reminder, hey, think about the temperature. Make sure you're below 77 degrees Fahrenheit. Is your pH in a range that's going to work for co-inoculation? And what's your alcohol level? Okay, so we've made it where we started, and that's the different types of strains that are available for winemakers to use. Think about the fermentation speed that you're looking for. Think about your wine's chemistry. What type of flavor are you hoping to achieve? And know that all of these strains have come from nature. They've been isolated from starter cultures from around the world. Let's take CH11. This strain, it might not be something for the Texas market. Maybe it is, but I'll give you just a little example of how we found it. That strain works really well in low pH wines, very popular in cold climates, customers in Canada or the Finger Lakes where I learned to make wine. This is a very popular strain because sometimes we have wines that we want to go through malolactic fermentation with a pH close to 3. And this strain came from a starter culture from a winery in Germany, which has produced wines at low pHs for hundreds, if not thousands of years. So they would use this strain to ferment their Pinot Noir and their Rieslings. And so we took that strain and we isolated it, and now we're able to provide this unique strain that has properties that work really well around the world. So let's talk about some strains that you may be interested in Texas. The first one that I want to highlight is CH16. This is an Oenococcus oeni strain that was isolated from a high alcohol red wine in South Africa. And so this wine was selected, this strain was selected to perform really well quickly in wines that go up to 16% ethanol. And so maybe that's a wine from Texas. Maybe that's a Zinfandel from Lodi. And I just included a little graph of how CH16 performs in that high alcohol wine. And it does produce a good amount, medium level, I would consider it, of diacetyl, which I think is really good for the use in barrel aged wines. Another unique strain is CH35. Not only does this strain perform really well at high SO2 levels, sometimes, maybe you added a little bit too much SO2 or you needed to add SO2 because maybe the grapes weren't so clean. You had to knock down some of that Acetobacter or Hansen yeast coming in. This is a good strain to use. Its other characteristic that winemakers will leverage is its ability to produce a lot of diacetyl. And if you are hoping to produce a California style Chardonnay with lots of buttery aromas, this is the strain that you want to use. And I also know a lot of winemakers that really believe that diacetyl is a key ingredient in their barrel aged red wine. So a lot of folks will use this in red wine as well. The sensory threshold for diacetyl is much lower in white wine. So you might have the same level of diacetyl in a red wine as you would in a Chardonnay, but you wouldn't perceive it like you would in those butterscotch aromas that are very clear in Chardonnay. And here's just a graph of the different amount of diacetyl produced by our different strains. And then finally, a strain that I think is really exciting is Venaflora Sine. And this is for all different types of wines, but I see it used very often in whites and in rosé, in wines that winemakers perhaps don't want those buttery or lactic characteristics of malolactic fermentation, but they want the stability that malolactic fermentation brings. And this strain is unable to produce any diacetyl. So it's kind of the opposite of CH35. It's not able to convert citric acid. And so that's how we came up with the name of Sine. So very good for elegant, crisp, clean styles of wine. Okay, well, that is all I have today. My goal was to introduce Christian Hansen, to introduce the story of how lactic acid bacteria, specifically Oenococcus oeni, was brought to the masses in a direct inoculation form. And a secondary effect of the story that I told is hopefully a call to action. It's twofold. That one, know the research, know the science, know your wines, know what you're hoping to achieve, but also have that exploratory spirit. And it's no secret that in Texas, you may not get the attention that regions in California or Europe may get. So I challenge you to take our products and use them in your wines and develop your own knowledge. And let's try to best use these products to make the best wines together. So I see this as a very good start for that type of relationship and to further our knowledge and make the best Texas wine possible. Thank you.
There was two questions that came in if you wanted to answer. What's the typical shelf life, usable life of the MLF bacteria? And what
Okay,
storage do you recommend
sure.
if
You
they're
know,
still on?
if they're still on. It depends on the format. I'm assuming that most of you are using freeze-dried. The freeze-dried bacteria products have a shelf life of 24 months if stored properly. You can go to the Guzmer website. They have all the product information sheets there letting you know uh, what temperature to store them at, how long the shelf life is, what the cell counts are. There's a lot of really good information available on the Guzmer website about the Christian Hansen bacteria range. Where are the products available? I'll let Jill or Chris. Guzmer is our exclusive distributor in the United States and Canada, so they're best suited to answer that question.
Yeah.
Yeah. Oh, Jill, I didn't know you were still on there. Go ahead.
Oh, yes, we, you cannot order directly from the website, but just reach out to me and I can get all that set up for you, and we'll get an account set up for you, and I'll send you over the information. So you just place the order through me or through customer service.
Okay, I see one more. Are there negative byproducts of co-fermentation? It depends. That's going to be my answer for most of most questions when it comes to fermentation. When you are conducting co-fermentation, it depends, and I do see risk if you are attempting to conduct a co-fermentation at high pH, because at lower pH, Oenococcus oeni is pretty much solely adapted to survive in that condition with high ethanol and low pH. When you have a higher pH, you're really inviting some other bacteria to enter the scene. I used to be a winemaker at a large winery in the Central Valley of California, and we had some problems in the Central Valley, very warm. We'd have pHs of 3.8, 3.9, and we would have some lactobacilli that would cause off aromas, mousiness, ropiness. So as a winemaker and hoping to create clean wines, I really like to get the Oenococcus oeni in early. I wanted the fermentation, that conversion to take place rather quickly. I wanted the Oenococcus oeni to outcompete. So, I think that's a concern if you're doing co-inoculation at a high pH. You got a concern of what else is coming in on the grapes and your winery equipment. The other concern that you might have is during primary fermentation. I was a fan of sequential inoculation, and I would ferment 88 degrees, 90 degrees. You have a little bit of ethanol and you start getting up to temperatures of close to 90 degrees, you're going to have a lot of death when it comes to your Oenococcus oeni population. And maybe not all of them die, but their population is going to be greatly reduced. And remember, they're slow growers, and you need 1 million cells per milliliter to convert malolactic conversion. And so you might be waiting a long time for your bacteria to convert malic to lactic. And if you're buying bacteria, you surely don't want to kill them. Okay, let's see, any more questions? Does cold soaking before primary fermentation affect the outcome of malolactic fermentation? I haven't seen any studies, that would provide a definite answer to that. There might be a few different variables, but my biggest concern, would just be controlling the population of other microorganisms. If you are going to have, Acetobacter in the beginning, during your cold soak that survives. Anytime you're doing a cold soak, you want to ensure that you don't have any BA increases, because that is a concern if you have an extended malolactic fermentation later on and you gain some BA if you already had some in the beginning. I'd be concerned about. One of the things that I like to do when I'm conducting a cold soak is I usually add some non-Saccharomyces yeast, Torspora delbrueckii, which we sell under the commercial name Prelude. It performs really well at high osmotic stress. So we call it bioprotection. You're using a known non-Saccharomyces yeast to protect your wine, allowing the antagonistic, the Saccharomyces, the non-Saccharomyces yeast that you really don't want on the grapes. It holds it back at bay. And then once you're ready to have primary fermentation take off, you can inoculate with your choice of Saccharomyces cerevisiae, and your wine had been protected during that cold soak. Okay. Let's see. All right, I think that is it. But as Jill said, reach out to her. She has a wealth of information, and we're always happy to hop on a call and work through any of the challenges that you may have. And I can certainly share my experience from different regions and the struggles of malolactic fermentations around the world with you and Jill. So I'm looking forward to learning more about Texas wine. I got to visit Lubbock and go to Fort Stockton and Fredericksville, and I really had some good wines. I was blown away by the Tempranillo. I even had a very good Sauvignon Blanc. And so I'm looking forward to trying more Texas wine with you all soon.
Thank you, David. Bye, everyone.
Bye-bye.